Welcome to Brain Vision.
In this problem, we have two smooth spheres A and B with identical mass. A is given a velocity of v0 while B is at rest. We want to determine the velocity of B just after it strikes the wall. Now, for the first impact, this occurs when sphere A strikes sphere B. When this occurs, the linear momentum of the system is conserved along the x-axis, along the line of impact. So if we take the right direction as positive, and we use the conservation of momentum, this tells us that the mass of A times its initial velocity, VA, plus the mass of B times its initial velocity before the collision is equal to MA VA1 after the collision plus MB VB1 after the collision. So putting our values in here, this is M V0 plus 0, while B is at rest, so it has no momentum. And this is equal to the mass of A, which is simply M, times VA1 plus M VB1. And so if we divide both sides by M, we get that VA1 plus VB1 is equal to the initial velocity V0. So assuming we know V0, we have only two unknowns in this problem, VA and VB. Now, if we choose again the right direction as positive and now use the definition for the coefficient of restitution, E, remember E is equal to VB1 minus VA1, that's the relationship between the velocities after the impact, over V0 minus, we'll write down the relationship first, that's VA minus VB, the initial velocities. So this is actually VB1 minus VA1, both of which are unknown, over V0 minus 0. And so we can see from here that VB1 minus VA1 is equal to this coefficient of restitution E times V0. And we can call this equation 2. So essentially we have two equations with two unknowns. We assume that we know the coefficient of restitution and the initial velocity V0. So if we solve equations 1 and 2 simultaneously, we find VB1, the speed of B after the first collision, is 1 plus E over 2 times V0, and the velocity of A, VA1, is equal to 1 minus E over 2 times V0. Both of these are to the right, so both balls move towards the wall. Now, the second impact occurs when B strikes the wall. Now, since the wall does not move during the impact, the coefficient of restitution can be written as follows. So this is our second impact. E is equal to 0 minus VB2. Remember, VB2 is the speed at which ball B strikes the wall, or ball B rebounds from the wall rather, over VB1 minus 0. Remember, the wall does not move, and so it has no velocity. And so E is equal to 0 plus VB2 over VB1, which we calculated before to be 1 plus E over 2 times v naught minus 0. And so we end up, if we rearrange this equation, with the final velocity of ball B after it strikes the wall and rebounds, vb2 is equal to E into 1 plus E all over 2 multiplied by initial velocity v naught.